Chapter 4, Day 8. Trigonometry from points. So you are given a point. How do you calculate the 6 trig ratios? So, given point -3, 4. Where can you find this point? X equal to -3, y equals to +4. -3, 4. Which quadrant does it fall? So this is going to lie in second quadrant. What's our sine, cosine, tangent values? So again, when we calculate the angles, it's going to be with respect to the x-axis. So please don't forget, it's going to be with respect to x-axis, the closest x-axis. So what is sine defined as? Sine is defined as opposite over hypotenuse. So we have to calculate the hypotenuse first. So if one side is 3, so your adjacent side is going to be 3. Your opposite side is going to be 4. 3, 4. Do you remember the Pythagorean triples? The hypotenuse is going to be 5. So Pythagorean triples. So don't forget, adjacent is going to be -3. Your y is going to be, your opposite is going to be +4. So what's sine defined as? So sine is defined as opposite over hypotenuse. What's cosine defined as? Adjacent over hypotenuse. What's tangent defined as? Opposite over adjacent. Opposite over adjacent. So normally we like to put the negative sign on the numerators. From here, do you think you can finish the next 3 trig ratios? Cosecant is going to be the reciprocal of sine. Secant is the reciprocal of cosine. Cotangent is the reciprocal of tangent. So this way, you just put down the ratios. So length over length, the side length of each, to figure out the 6 trig ratios. 6 trig ratios. Number 2. So this time, both of the numbers are negative. So do you think you know where this point is going to lie? So x equal to -12. So mark on your paper -12. -5 in the y directions. So it's going to be somewhere here. My graph is not drawn to scale. You should have a better graphing on your paper. I'm just marking it for the reference for your visualizations. So where is this reference angle? Again, it has to be with respect to the smallest one that makes with the x-axis. So it's going to be this small angle here. But do we have the side for each? So if one side, if the adjacent side, again, adjacent is represented as your x. Adjacent is always your x. Adjacent side is going to be -12. Your opposite, so now it's in third quadrant, it's going to be -2, -5. What's going to be the hypotenuse? So do you remember the Pythagorean triples? 5, 12, what's going to be the hypotenuse? It's going to be 13. And you can definitely check it yourself. 12 square plus 5 square equals 169. Square root of 169 is 13. So do you think you can write out sine theta, cosine theta, tangent theta? Sine is defined as opposite over hypotenuse. Cosine is defined as adjacent over hypotenuse. Tangent is defined as opposite over adjacent. Opposite over adjacent. And then because it's in third quadrant, it would have to be positive. From here, the next 3 would be, so take the reciprocal of sine for cosecant. Take the reciprocal of cosine for secant. Take the reciprocal of tangent for cotangent. So there you have the 6 trig ratios if you're given a point. So whenever it comes to given points, mark it down find the quadrant and then identify which one is going to be positive, which one is going to be negative. And if you use the rules that I mentioned, x is always going to be your adjacent side, y is going to be your opposite side, you will get to the answer fairly quickly. Question number 3. State the quadrant in which theta lies. So this comes to which quadrant of the functions of the 6 trig ratios is going to be positive or negative. So you will know the characteristic. And I mentioned you can use the shortcut of all scholar takes calculus. All scholar take calculus. Or if it's easier, that I like to associate with x and y. So first quadrant, second quadrant, third quadrant, fourth quadrant, to find which of your 6 trig ratios is positive or negative. So let's take a look. Number 3, it states sine theta would have to be positive, cotangent theta would have to be negative. So which quadrant will you find sine to be positive? So when it comes to sine, I know it's going to be the opposite side. Opposite or the y. So where will your y be positive? So in order for you to have positive sign, it's going to be in the first and the second quadrant. It would have to be first and second quadrant for sine to be positive. Where will your cotangent be negative? So cotangent is going to be adjacent over opposite. So which part will you have negative cotangent? So negative cotangent means that it's going to fall in the second or the fourth quadrant. So which one is the one that shows for both, satisfy the both? So obviously it would have to be in the second quadrant. So the answer that you will find, in order for you to have a sine greater than 0, tangent less than 0, it's going to be, the angle measurement is going to be in the second quadrant. Number 4. Tangent is positive, cosine is negative. So which quadrant does this angle theta lies? Tangent to be positive, it has to fall in the first or the third. For tangent to be positive, it would have to be first or third. Cosine is negative. Where will your cosine be negative? In order for cosine to be negative, it would have to be in the second or the third quadrant. Second and third. So which one satisfy both? So obviously it has to be in the third quadrant. So the theta is going to lie in the third quadrant. So if you have an angle in third quadrant, both of your conditions should satisfy. Your tangent should be positive, your cosine should be negative. Number 5. So this time secant would have to be greater than 0. Secant is positive. So when it comes to secant, I like to think of cosine because secant is the reciprocal of cosine. Cosecant less than 0, so that means sine would have to be less than 0. Sine would have to be less than 0. So where is cosine positive, sine negative? Cosine is positive in first and fourth quadrant. First and fourth. Where is sine negative? Sine is going to be negative in the third and the fourth quadrant. So which quadrant satisfy both? Obviously, it's going to be in the fourth quadrant. So the quadrant that satisfies both of the conditions, that your cosine is positive, your sine is negative, or secant is greater than 0, cosecant is less than 0, is going to be in the fourth quadrant. In the past, from my experience, I have so many students confused on this part. So make sure you study and figure out the 6 trig ratios will be positive or negative in each quadrant. Number 6. Find the values of sine, cosine, and tangent given the followings. So first you are given sine theta equals negative 4 over 5. So if you know sine theta equals negative 4 over 5, can you make that as opposite over hypotenuse? Opposite over hypotenuse. And since your opposite side is a negative, and we know theta lies in the 4th quadrant. So can you go ahead and mark it down? Opposite over your hypotenuse. So that means your opposite side is going to be negative 4. And how about your adjacent side? So again, is this the Pythagorean triples? Is this the Pythagorean triples? The opposite side is negative 4. So our adjacent side is going to be 3. And of course, you can use your Pythagorean theorem to calculate. If your hypotenuse is 5, what's going to be your adjacent side? So you can calculate it. Adjacent square plus opposite side. So opposite, we know it's going to be 4 squared equals the hypotenuse square, which is 5 squares. So this turns out to be adjacent is going to be 3. And I just took the shortcut of using the Pythagorean triples. So with that, can you figure out the 3 trig ratios that the question asked? Sine theta, we are already given this value. Sine theta is a given, so negative 4 over 5. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So this is not asking you to calculate anything. It's simply plug it in the side length. Again, trig ratios are just taking the side length. Number 7. You have cotangent theta equals negative 13 over 12. So whenever it comes to cotangent, I'm not so familiar with cotangent, so what do? I'll just rewrite into tangent. And don't forget, tangent is the reciprocal of cotangent. So when I rewrite into tangent, I have to make sure I take the reciprocal of cotangent's value. And I know theta is going to be in between 0 and 2 pi. So where can I find a negative number for tangent? Well, between 0 and 360, there could be 2 answers. There could be 2 answers for this one. Because tangent, to be a negative value, it's either going to be in the 2nd quadrant or the 4th quadrant. So how about us limiting the information to just the pi, which means just to 180 degrees. If we limit it to 180 degrees, the only possible solution is going to be in the 2nd quadrant. So your theta would have to lies in 2nd quadrant, with your tangent a negative value and between an angle between 0 and 180 degrees. So for tangent theta equals negative 12 over 13. That means opposite over adjacent is going to be negative 12 over 13. So what is the hypotenuse in this case? What's the hypotenuse? Hypotenuse is going to be 12 squared plus 13 squared equals, so 12 squared is 144, 13 squared is 169. So that equals to 144 plus 169, 313. So our hypotenuse is going to be the square root of 313. Have you noticed that I'm not trying to use my calculator to turn this into decimal numbers? Like I said, trig ratios needs exact values. So whenever it comes to calculations, you can just keep it as the irrational numbers. So square root of 313 works for us. And if it's in the 2nd quadrant, so our opposite side is going to be negative 12. Our adjacent side is going to be, opposite side is going to be positive 12. Adjacent is going to be negative 13. Adjacent in 2nd quadrant, so your adjacent would have to be negative 13. Your y is going to be positive 12. And our hypotenuse is, as we calculated, going to be square root of 313. So sine is going to be opposite over hypotenuse. Cosine is going to be adjacent over your hypotenuse. And then tangent is a given, which is negative 12 over 13. So to wrap up today's lesson, make sure you identify which trig ratios is positive or negative in each quadrant. Identify the angle theta. Then you can calculate the numbers accordingly.